Okay, let's start.
Okay. Good morning, everyone. Today I'm going to inform you about machine learning in computer vision. This study explored the machine learning application in computer vision and predict future prospects. In this slide, the most recent applications are object detection, object classification, and extraction of relevant information from image, graphic documents, and videos. At the same time, we can say that the object detection and analysis are an important part of everyday life. As a matter of fact, it has application in avoiding traffic collision, facial expression recognition, and emotional recognition based on human posture. On the other hand, the computer uses the image and pattern mappings in order to find solutions and to maintain the monitoring, inspection, and surveillance tasks. For example, here figure one provides information about classification, object detection, and instant segmentation. At the same time, figure two shows the object detection such as cars, well as person in image applying deep learning and faster RCNN inception B2 model. Um, the machine learning models for computer vision are support vector machine and convolutional neural networks using image recognition and classification and probabilistic graphical models. As you can see in figure 3, the object detection process in the machine learning and computer vision environment. Um, Regarding machine learning in computer vision, we can mention that has been studied the use of computer vision and machine learning in medical science, such as retinal blue vessel, nuclear medicine, what else? Endoscopy or ultrasound and uh, in this line, machine learning and computer vision has new application in engineering, medicine, agriculture, sports education. We can see this application in table one. For example, agriculture production. The agriculture fields and land cover is made after processing the satellite image and are classified using machine learning algorithms such as random forest. Also, traffic detection. The detection of traffic flow is predicted using computer vision and machine learning techniques. Also, bleeding detection, endoscopic image enhancement, and clinical decision support. It has been used computer vision and machine learning for breast cancer diagnosis. At the same time, figure 4 shows the evolving research areas in machine learning and computer vision. We can see here advancing areas of research in this field as the biological science, 19%, and human activity, 19%, followed by traffic management, 14, and professional sport, 13%. Although the computer vision interprets and extracts information for audio and video and can work independently of machine learning. However, machine learning add the predict feature of already processed data. Figure 5
1
shows
minute
the
left.
okay. Figure 5 shows the undergoing research in machine learning and computer vision with respect to time. The majority of research in the area started 2015 during the the last 3 years, the research has been on agriculture, biological and medical science, human activity interpretation, analysis, and prediction of sport, traffic management, and control in the cities. As a final conclusion, we can say that the research has identified the successful implementation of machine learning application in computer vision for weather forecasting, biological science, expression reading, food security, sports, and predicting maintenance and industry. That's all. Thank you for your attention.
Okay. Good morning, everyone. I will talking about of this paper called Microfluidic System for C. elegans culture and oxygen consumption rate measurement. Here, they present a microfluidic culture system for C. elegans with integrated luminescence-based oxygen detection. The material used was stoichiometric thiol in epoxy or OSTE to measure oxygen consumption rates or OCR on the chip due to its low gas permeability. With this microfluidic approach, it was possible to confine a single nematode in a culture chamber starting from the L4 stage and studying it over a time a span of up to 6 days. Okay. For oxygen detection applications, it is necessary to avoid rapid oxygen replenishment to the culture medium in order to measure the depletion generated by the biological sample. Polymer has similar properties to thermoplastic that are nearly gas-tight, adjusted to minimize oxygen uptake and properly measure oxygen consumption rate. Here you can see the OSTE culture chamber layout with channels and filter structure on the inlet and outlet side, allowing the loading and capture of individual L4 worms and has a sensitive dye spot to oxygen that is integrated in the center of the channel. Bright field microscopy image of the worm's culture chamber with the oxygen sensitive dye is in black deposit in the center. And here you can see the luminescence at 0 OD and 100% OD. Higher emission intensity is measured in the case of oxygen depletion. In this image, you can see the light emitted by the oxygen meter is guided through an optical fiber and the glass slide to the oxygen sensitive dye. This generated a light signal dependent on the oxygen concentration. The microfluidic chip is held in a holder. The inlet and outlet are connected to a syringe pump filled with bacterial food and to the waste reservoir respectively. The chip is mounted on the motorized deck. This is a diagram of the flow protocol which comprises 3 complete cycles of successive phases of feeding and measurements during 1 hour. Each cycle has a fluidic pulse to wash the embryos and progeny, continuous injection of bacterial food suspensions and simultaneous oxygen replacement on the chip, and 30 minutes time for measurements of OCR during which the flow was stopped. And here you can see the oxygen concentration on the chip during the culture cycles of the control in blue, and for the chamber that houses a single worm in black. When the flow stops, the oxygen concentration begins to decrease. Here, OCR values extract for the control and the nematode as assay. The The development of the worm was observed, and the normal morphology was confirmed. However, compared to nematodes growing on standard NGM plates, the development of on chip worms was delayed, probably due to less oxygen in the chip. The OCR profile of a single worm shows a trend indicative of an increase in respiratory rate from larval stage of adulthood and a decrease for the worm reaching old age. This figure shows that the profile evolves in a similar manner as a function of age, with higher OCR values during the reproductive phase of the organism. For the metabolic test, basal and maximum respiration rates were evaluated during respiration. Here they show a control experiment without a population of worms with oxygen consumption by the culture medium. After trapping the worms in the culture chamber, oxygen is rapidly consumed within 15 minutes, indicated that the contributions of the worms to DO depletion is dominant. Subsequently, the worms were exposed to a high concentrations of sodium acid to inhibit respirations. The DO depletion rate is reversed, indicating that respirations has stopped. Um, in conclusion, in the future, more versatile assays can be performed using drug injections or compounding along with worms' imaging capabilities. This promising technological approach can be combined with other analytical methods, opening the way for new insights into the coupling of anabolic and catabolic processes in living organisms. That is all. Thank you.
Good morning, everybody. Today I'm going to present this paper, satellite image classification using convolutional neuronal network. In this research, the authors designed a novel method in order to classify different objects inside remote sensing images. The principal component of this research is a convolutional network and principal component analysis. So remote sensing images are used with very different purposes. For example, prediction of disaster, prediction of weather, study of urban places, and different soil types in order to study the different kind of evolution of areas. So neural networks in this case are used to classify different objects in images, for example, snow, soil, water, etc. The methodology is described in this image with different stages. The input are the multispectral satellite image. The second stage is the principal in order to process an image, for example, the normalization or the preprocessing data. And the 3 and 4 stage in this research are the principal component, which include broad transform and principal component analysis. And neural network is used to describe the different objects. And finally, the stage of classified image includes the machine learning algorithm in order to describe different objects. The image fusion, according to the Broadway transform, is used to combine the different information of different channels of color space. Normally, images are composed with RGB canon. So in this case, this transform allows to fuse without lost information. Principal analysis component is the statistic tool in order to reduce the dimension of data, which are composed according to the covariance matrix and the agent vector. Neural network in this case are used according to the convolutional with K filters to extract different features in order to differentiate and describe objects. In general, the convolutional network are described with this image with different stage. In this part, in the first part, the input image are extracted features according to the different convolutional network and pooled layer. And finally, the final stage are composed according to the different objects. This layer is composed according to the different objects to describe. In this table, the authors presents the different bands of satellite image according to the wavelength length and resolution. In this image, the left one is a satellite image with raw data, and the second and the right one describe the classification. In this research, 5 different objects are classified with different colors. For example, vegetation, water, urban area, snow, and cloud. So in this table, the results are present with a kappa value, which are standard in satellite image processing. And the accuracy of this research is higher than 90%. So it is a very good value. In this table, finally, the author presents the proposed method compared with another standard methods, which is compared according to the kappa value, which is a value 0 between 1. In this case, all methods is near to 1 value. And the proposed method is the 94 per 5%, and is higher than another methods. So as conclusion, the convolutional network in this case, and remote sensing image, is a very good classifier in order to describe different objects in image. That's all. Thank you.
Hi everyone, I'm going to present this paper, Controlled 3D Culture of Beta Cells and Endothelial Cells in a Micropatterned Collagen Sheet for reproducible construction of an improved pancreatic pseudo-tissue. In this paper, they propose a geometrically controlled pancreatic model constructed from a co-culture of beta cells and endothelial cells. They fabricated a geometrically controlled pancreatic co-culture platform using micropatterned collagen sheets containing randomly mixed mouse pancreatic beta cells and mouse pancreatic islet endothelial cells. They use a paper support for better handling of the freestanding collagen sheet. So the paper support was loaded into the micropattern mold and then was soaked with this cell collagen mixture. And after the collagen gelled, the collagen sheet was harvested from the mold by picking up the paper support. To observe the morphological change of the sheet induced by each cell type, beta and endothelial cells seated in the collagen were cultured for 4 days. The initial shape and dimension of the micropattern were maintained throughout the culture days, and the cells aggregated to form small clusters with heterogeneous size, possibly explained by the aggregating characteristic of the beta cells. They also observed the effect of cell concentration on sheet morphology, and they saw that a lower concentration of beta cells resulted in small size clusters. A higher concentration of beta cells, the pattern dimension was larger. And this indicates that higher beta cell numbers occupy space, and thus the endothelial cells were unable to surround them and make a bridge compact. Regarding endothelial cells, a lower number fails to bring the beta cells to the center to form a cluster, while a higher number fails to give sufficient space for the beta cells to remain within the pattern. Figure 3 here shows the fluorescence images of the co-culture sheets, and on day 0, the cells are randomly distributed among the micropattern. On day 4, the dimension of the micropattern has slightly shrunk, and the beta cells aggregated to form small clusters, while the endothelial cells seem to have proliferated and migrated mainly to the pattern edge. On day 7, the endothelial cells have proliferated and at the pattern edge to form a vessel-like structure that encloses the pattern, while the small beta cell clusters have aggregated to form bigger clumps. On day 10, beta cells have formed a completely packed cluster that fills the island, while the endothelial cells tightly surround all these beta clusters. The cluster size are homogeneous between 100 and 200 micrometers, which is similar to the biological pancreas. So, to check the cell arrangement within the sheet, the cell nuclei were stained. In the bridge, a monolayer of cells is lined on the edge, while no cells are observed inside. This indicates that the endothelial cells form a monolayer of a vessel-like structure. So when they observe the same position in the nucleus image, in D, they noticed that the vessel-like structure was hollow inside because no nuclei were seen. Also, they tested cell viability, and they saw that it was maintained more than 95% until day 9, but then decreased by day 15. Nonetheless, the cells co-culture in these pattern collagen sheets maintained high cell viability of over 85% for about 2 weeks. Also, to observe the effect of having the micropattern within the co-culture sheets, it was compared with a bulk collagen sheet without any micropatterns. With a micropattern, the area is reduced to about 62% of the sheet without the pattern, which means that the cells can occupy less space. However, the space of the micropattern, the shape of the micropattern, gives the cell a guideline to grow alone. Also, with the macropattern, nutrients and gas can reach the cells more effectively because the culture media can flow through the cavities. Compared to the bulk sheets, the endothelial cells within the micropattern sheets were lined along the edge of the pattern in a thin and elongated shapes, while the cell maintained a non-elongated and rather circular shape in the bulk sheets. The monoculture beta cells within these micropatterns sheet show more controlled distribution compared to those within the co-culture bulk sheets. However, they do not tightly aggregate without the endothelial cells. And finally, these results were also associated with the difference in the functions of insulin secretion, and they saw that the secretion level of the co-culture condition were 2 to 3 times higher than those of the monoculture condition. Therefore, this micropattern improved the pancreatic function. Thank you.
Okay, my topic is an automated microfluidic system for morphological measurement and size-basic shorting of C. elegans. Okay, this paper mentioned about an automated microfluidic system based on morphological measurement and the size of the C. elegans worm. This function is performed based on the detection of worms. Based on real-time vision and sizing algorithms. The valves developed for sequential loading order from individual worms. 319 worms were used, and an average speed of 10 worms per minute was achieved. Okay. Okay, in this part, the worm classification system was established based on an inverted microscope to control the valves. 16 control channels were developed, used to regulate the pressure. The chamber and the pressure unit were controlled by a computer. Okay, in this part, the microfluidic device consists of two layers of microchannels, as indicated in blue and red. The channels were placed in the flow layer to manipulate individual worms. The valves were integrated in a lower control layer. In part C, the valve show in figure to show its operation. The height of a channel of the flow layer designed at 45 micrometers is the same diameter of a young adult. The microchannels in the upper flow layer are divided according to their functionality, observation camera, classification channels, and the worm loading chamber is 60 micrometer, and the observation chamber is 300 micrometer. There is an inflow that the worm's entry velocity and leaves a longer response time for the valves to the observation chamber and catch the worm loads. Okay. Okay. In this part, in the worm detection algorithm, the pixel intensity of an area in the observation chamber is used a reliable indicator of the presence of the worm. And this part, before a trial begins, a region of interest is selected, which lowers the observation chamber, and once a worm image is taking unnecessary features and removed from the edge of the camera, then residue is removing the image, and contours are identified, and worm-bound areas are detected. And the conclusion, this microfluidic system an image processing for automated classification based on C. elegans is very important. Thanks.
Guys, who is next? Are you there? Luis.
No sabía que me tocaba a mí, pensaba que era el último.
Andrea put the list
No,
in the message area.
yeah, Luis, you are
You are
next.
the next one.
Excuse me. Hello everyone. Today I will present this article that studies the spontaneous buckling in actomyosin sheets and actomyosin sheets. These allow us to understand cell growth and shape change in tissue development. This paper studies the actomyosin network behave as poroelastic materials, and a generalized hydrodynamic theoretical model is used to study the dynamic contractions of the network. The equation of motion is solved numerically using parameters obtained from the experiment. This paper is this paper has a strong experimental work. In these articles, they demonstrate the fabrication and dynamical properties of initially homogeneous thin suspended elastic actomyosin. In these figures, we can see these lamin, these sheets, which grow into a chamber with aspect ratio A0 and H, the height of the chambers. In the figures B, the actomyosin sheet were generated by polymerization actin, and this picture shows the evolution of the systems. In these figures, we can see the growth, and after the contraction of the shed actomyosin. And the velocity of the contraction of this system is plotted here. At first time, the shed grows linearly, and after this contraction occurs exponentially with relaxation time of the 20 seconds, tau. The contraction of the sheet is plotted in three-dimensional graph plot here, and the contraction occur in isotropical in the space. that means is equal in the x in the plane of xy. After the models use of this author is this equation. The theoretical model used the hydrodynamic generalized theory, and the actomyosin is characterized by U, and the solvent is UV. Sigma L and sigma at correspond to constant, characteristical constant of the actomyosin and the yields of solvent. The equation is resolved by numerical methods, and this is necessary to use the experimental parameters of the before figures. In this case, the models is very well to explain the contraction of the lamina of actomyosin. In these figures, this contrast the models and the experimental parameters of the velocity growth, and the line is the models and the circle are the experiments. Thank you very much.
Good morning, everyone. Today I'm going to talk about this paper called Upscaling of Pneumatic Membrane Valves for Integration of 3D Cultures on Chip. So first, let's see what are these pneumatic membrane valves. These valves are formed by two channels, orthogonally located. So one is the control channel and the other one is the flow channel. So here the authors propose to integrate a microfluidic large scale. It means because to culture spheroids, for example, you need more than 10 microns length. So that's why the 3D printing in the zeta axis has a limitation, but with these new materials that they propose to use, they can fabricate these pneumatic membrane valves in order to achieve the lengths that are needed for biological experiments as spheroids or embryogenesis. So let's see, they use 3 cell lines. The first are the mouse fibroblast. Also, they use human-induced pluripotent stem cells and human adipose liver adult stem cells. So let's see here in the figures. Here's how they use 3D printing to produce these molds. And as you can see, there is a staircase channel profile. So to produce these bulbs, they need to make this staircase effect to minimize it. And how do they do it? They use two strategies. So first, they are going to use the anti-aliasing, as you can see in figure number 1 at the D section. You see that this comparison. So here's the mask without anti-aliasing, so you can appreciate the staircase effect. And then with anti-aliasing, it means that pixel by pixel, they are going to control the gray scale of each pixel, and that's how this is called anti-aliasing. And with this strategy, they achieve a round profile. As you can see at the E section, with the confocal, they obtain these profiles, and you can compare them. So without the anti-aliasing, it is with the staircase effect, while they apply the anti-aliasing, you see that they obtain a rounded channel. So that was the first approach. And also at the F section, you can see and compare the PDMS that resulted. So that was one of the strategies. The other strategies was to use a wax that is called super wax, and they made we're going to check that out in a few minutes. But here I wanted to mention that in the section C, you can see how the pneumatic membrane valve, how it closes according to the pressure that they apply. So you can see that with 50 kilopascals, you cannot close completely the valve. But while you increase the pressure, like 100 kilopascals, and with 200 kilopascals, you achieve that the valve is completely closed. So let's continue. So here's the second strategy that they use. You see that they use this wax mold. They reflow it so that it completes the polymerization, and then they use this Duracell mold. It is a negative mold, and from it you can cast the PDMS. And here also you can see the difference between here in the section B in figure 2, you can see how the profile is with the staircase, but when you use the reflow, the profile is round. You can also see the profile measurements comparing the section C. You see how it becomes round. All right, so let's see how these valves act. So here you can appreciate that the valves in the section A of figure 3, they use first to seed the cells, then to trap the cells, and then while the cells are trapped, the spheroid is formed. So
1 minute left.
Thank you, Andre. Here are the cells cultured and how they are dispersed. And after 24 hours, the cells form this spheroid. And the size of the spheroid is controlled also by this, the length of the valve. And you can see that with the cell lines that they use, they obtain these spheroids with these diameters. And also they use them to combine these. So they label fluorescently two cell lines of fibroblasts, and you can see how in 65 hours the two spheroids merged. And so that's very exciting. All right, thank you very much.
Hi everyone, can you see my screen?
Yes.
Thank you. So, okay, I'm going to talk about this review called Bioprocess Microfluidics, applying microfluidic devices for bioprocessing. So, as we know, we in the field of bioreactors, we have struggled with the costs and the material. So this review is about the miniaturized bioreactors, and they know that this process have treated as a tool to obtain relevant data during early stage of these developments. So the microfluidic devices are an attractive alternative in bioprocessing development due to the high degree of control over process variables afforded by the laminar flow and the possibility to reduce time and cost factors. So it is estimated that over 10,000 experiments are necessary for a single bioprocess development project. So from primary strain screening to pilot scales trials. So to reduce further cost and time involved in process development, miniaturized bioreactors are used as an alternative to bench scale bioreactors. So when this is combined with design of experiments approaches, the total number of experiments required is reduced, and which can minimize the number of more expensive large-scale experiments. So with microfluidic devices, as with traditional bench-scale reactors, they can, in principle, be operated in batch, fed batch, and continuous modes under a broad range of process conditions. So by monitoring of key process variables in microfluidic devices is typically achieved with optical sensors. And there is still a need to implement robust and sensitive online and in situ detection methods in order to obtain quality data and achieve a high level of process control. So we have different types of bioreactors and bioprocess, like other end cell culture devices, flow biocatalysis with continuous enzymatic catalyzed reaction. But I want to put you to know this bioprocess. Microbioreactors for submerged microbiological cultivations. So these microbioreactors, these bioreactors with working volumes in the sub-milliliter range, and despite the lower throughput compared with microtiter plates, these reactors offer a controlled microenvironment and batch, fed batch, and continuous culture operation. The majority of these microbioreactors make use of the advantages of polymers, such as the gas permeability of the PDMS for the aeration of the culture. A high optical transparency of the polymers facilitates integration of optical detection methods. The layout of most of these microbioreactors is planar and horizontal, with mixing occurring in the plane either by spin bars or by peristatic motion of the chamber ceiling.
1 minute left.
Monitoring in microbioreactors is almost exclusively achieved by optical sensors due to their small footprint, which allows easy And these sensors have been shown to measure time profiles of pH, oxygen, and CO2, monitoring the individual analyte as well as multi-analyte monitoring. Further, these developments in sensing technologies are required to detect nutrient consumption and product formation. And finally, the opportunities that they show us is the limitation of further uptake in industry of miniaturized device lies in the lack of a more comprehensive monitoring of all process variables and sufficient automation, insufficient sample volume for quality control, and integration of downstream processing. And that's it. Thank you, everyone.